Welcome guys to another Project Euler episode. This is problem 19, Counting Sundays. You guys may wonder why I did 3 in one day. It's not because I don't have a life. I completed this in 15 minutes and I just thought I should celebrate today and go crazy making videos for you guys. So hopefully you learn something. Hopefully you surpass me in doing these problems someday. But this one, we'll keep going here. Counting Sundays. You're given the following information, but you may prefer to do research for yourself. This is actually true for all of them. You can do research yourself for all of them. But anyway, the 1st of January, 1900 was a Monday. 30 days has September, April, June, and November. All the rest have 31, saving February alone, which has 28, rain or shine, and on leap years, 29. A leap year occurs on any year evenly divisible by 4, but not on a century unless it's divisible by 400. How many Sundays fall on the first of the month during the 20th century, which is the 1st of January 1901 to the 31st of December 2000? You can take all this information, if you're using Java, you can take all this information and throw it out the window because we will not be using it. Java has something called the Gregorian calendar. So you want to import Java, and I forget what package it's in, so bear with me. I guessed it right. It's Gregorian calendar. I can't even spell it. But you want to import that package. It is perhaps a godsend if you believe in that sort of thing. It is amazing for this problem. So what we're going to do is we're going to make a variable for Sunday. And that's going to equal 0. The reason being, the way this is set up, Sunday is 0 and then Saturday would be 6. So Monday would be 1, Tuesday would be 2, and so on and so forth. So we want to make a variable for the year and a variable for the month. So down here we'll make int year equal to 1901 because that's where we're starting, and the month equal to 0 because we're starting with the 0th month, or January. So next we want a variable to hold the number of Sundays, and that's going to be 0 since we didn't start with any Sundays yet. So num Sundays equals 0. Finally, we want our Gregorian calendar object. Gregorian calendar, cal equals new Gregorian calendar. I can't even spell that thing, so yeah, bear with me. Now the constructor we're going to be using, this has multiple constructors, is set in the format the year, followed by the month, followed by the day. So the year we already have, we're going to input year, the month we have, and also the day we have, Sunday. So we have all the variables we need right here. Sorry, my nose is stuffed up. So we want a loop to go through while we are in the 20th century. Otherwise, we're just going to keep adding months until we reach the 20th century, or until we reach the 21st century. Excuse me. And yeah, that's basically what we're doing. So while cal has a method called get, and to get something you have to call a field. So year is a static variable, and it's also it's really weird. The Gregorian calendar object is very, very weird. So we want this to keep going while the year is less than or equal to 2000. because once we get to 2001, that is the 21st century. Hallelujah. So, what do we want to do? Well, if it's Sunday, we want to increase the Sundays. So let's just write that. If is Sunday, calendar, num Sundays plus plus. That's a method we're going to create. Don't worry about it yet. All right, next thing we want to do is increment the month, or if the month is 11, we want to increment the year instead. So what we're going to do is test if the month is greater than or equal to 11 first. My goodness, my nose. And if month is greater than or equal to 11, we need to increment the year, and then we need to reset the month variable, or else it's just going to keep going to this. So what we're going to say is month is equal to 0, okay? And then year plus plus. We're going to increment the year. If the month isn't 11, we're just going to increment the month. Okay. Now this is all set and dandy, but incrementing the year and incrementing the month is not going to do anything. Okay? Just because you increment the year here doesn't mean it's going to increment inside your calendar. So right here, we want to say calendar.set. You need to reset your calendar, and you want to set the calendar year equal to the year. And this is how you do it. You just say cal.year and then year. And the set method just takes a field, and then it takes whatever number you're setting it to, which will be the new year. So say it's 1902. It'll set year to 1902. So down here, we're just going to increase the month. Since we're going to be doing it for both anyway, we're going to increase the month here, or set the month here, sorry, and set the month here. We might as well just do it down here. So, yeah, cal.set, and we're going to set cal.month equal to the month. See, that's simple enough. Okay. So that's all we, except for the method, that's all we need right here. And the reason we can do this is because since we're incrementing the years, this will eventually break out because we're incrementing the years, setting the calendar to that new year. So eventually we're going to get above the new century. So we're all good there. We double checked it. So let's system.out.printf the number of Sundays that fell on the first of the month is %d%n. And we're just going to say num Sundays. And that's all we're doing. We're just calculating the Sundays that fell on the first of the month. That's why we're not incrementing the day at all. That's why we made this final, because we always want to check for a Sunday, right? Yes, we always want to check for a Sunday. And we're doing that here by taking the first of the month. Yes, we're taking the first of the month, checking if it is Sunday. And if it is, we're just adding 1 to the Sunday counter. By the way, this is the day variable. So it's not always going to be Sunday. I don't know. It's easier for me to mark it as Sunday because I know what I'm trying to get. But that doesn't necessarily mean, like, if you keep incrementing the month, it's not always going to be Sunday. It can, vary between Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. It just depends what the first of the month is. This is just telling it that, well, it's telling me that I'm looking for Sunday. I didn't mean to confuse you guys there. Public, static. And since it is Sunday, that tells me it's a Boolean because, oops, Boolean methods are usually accompanied like is Sunday or like is married. It can be answered with a yes or no question. That's basically I don't know the word for it right now, like standard. So since we're sending down the calendar, we need a Gregorian calendar object. We'll just call that cal again. And we're going to return cal.get. There's a set and a get method, like all objects should have. So what do we want to get? Well, we want to get the current day of the week. And if that current day of the week equals Sunday, then we want to return true. If it's not Sunday, we want to return false. So we want to get the current day of the week, so day of week. And we want to see if that's equal to cal.sunday. So is the current day of the week equal to Sunday? If it is, it's going to return true, increment the number of Sundays. If it's false, it's going to say false, skip over this line, increment this. And this is our whole thing. So the number of Sundays that fell on the first of the month is 171. And that is true. There are 171 Sundays that fell on the first of the month in the 20th century. Thank you guys for watching. Please subscribe if you like this video, or even if you didn't like it, because it makes me feel good, and I will know that you want me to make more videos. So please watch again for the next video.